The following organizations have provided funding for this Into the Outdoors television series.
Da-da-da-da-da. Da-da-da-da-da. There's something strange in the refinery. Woo! Who are you gonna call? Oil busters! See this stuff? It's crude oil. You know, the hydrocarbon liquids from ancient decomposed life? It's not worth much like this other than greasing the axle of your covered wagon.
So it makes you wonder, how can we use science, technology, engineering, and math to turn that worthless crude into the transportation fuels that make our modern lives possible?
Well, you won't have to wonder for long. See these? They're 2 science investigation passes into one of the most sophisticated oil refineries in the nation. And with your help, we're going to decode the science of turning this gunk into transportation fuels.
Plus, we'll discover the science of how it's transported as we head into the outdoors.
While they go figure out how they turn that crude oil into transportation fuel at the refinery, let's bring up some online science about crude oil to figure out where that gunk even comes from. Origin of crude oil. Here we go. Whoa, so much for the misconception that it's made from decomposed dinosaurs or ancient forests. In fact, it wasn't formed on land at all. It was formed in marine environments a long, long time ago. Looks like we need to go microscopic here. What? Oil from those little things? You're kidding. Hundreds of millions of years ago, ancient seas began teeming with life. Some of the most abundant made up the base of the ancient food pyramid: algae and zooplankton. Like all life, these little critters eventually died and their tiny bodies settled to the bottom of the sea, where many were covered by sediments washed in from the land masses. One of the keys to these little guys eventually becoming oil is being trapped in a sediment layer. This layer also had to be free from oxygen, anaerobic. As more accumulating sediment layers buried them deeper, pressure and heat essentially cooked their organic matter into hydrocarbons. Ta-da! Crude oil. Of course, you can't just drill for it anywhere. Geologists need to know where it has accumulated in a reservoir. As increasing sediments bury and compress the mud and sand containing the organic stuff, the trapped fluids, including hydrocarbons, get squeezed out. They migrate or flow upward through the interconnected pore spaces in the sediments. They call that porosity. Eventually, they can't flow upward past impermeable layers of rock, such as rock salt or anhydrite. And if geologic conditions are right, they get trapped in a section of porous rock. And that's your reservoir. And there you have it, crude oil. Now, depending on where you find it, crude can vary in color and viscosity, from a watery yellow to a syrupy green to a jet black that's as thick as milkshake. But turning all those different types of crudes into the refined oil we use today takes some serious science and technology. Fortunately for us, that's exactly what they're doing down there.
Now that you know where crude oil comes from...
I'm pretty sure they said it comes from those pipeline connections over there.
All right. You can explore pipelines later with Emily. As I was saying, now that you know how crude oil was formed, let's figure out how this place refines it into the jet fuel in our planes, the asphalt on our streets, and even the gas in our tanks.
I think we should get some answers from some real experts. Take a second to make a list of 4 things in life that you wouldn't want to live without. Then cross off the things that weren't made from or by using hydrocarbons in some way. Got any left? Didn't think so. So yeah, I think we can all agree that we need refined hydrocarbons in our lives.
So before we can make your batch of gasoline, we need a feedstock. We start with crude oil. Most of the crude oil that we process here comes from either Canada or North Dakota. Crude oil consists of hydrocarbons, and they can be as small as 1 carbon atom with 4 hydrogens, or they could be 20 to 30 to 40 carbon atoms with hydrogens. So depending on where you get your crude oil, that determines the different composition of hydrocarbon chains in the crude.
Do you have enough gas in your tank?
No worries, we're about to fire up that distillation tower and begin making a fresh batch. Stay tuned, there's more science here to discover than you imagine.
If you want to find out more about the science in refining crude oil, go to intotheoutdoors.org. So here's the deal. We already discovered that crude oil was made from decomposed marine life, but it was real tiny stuff, like zooplankton.
Yeah, real tiny things. And geologically, it got trapped in a rock reservoir down there in the earth. Not in these big caves, but in these little tiny pore spaces within the rock. That's called porosity.
Then it was drilled into. The crude produced and piped here for its first stages of refining, which is, whoa, that's a big thing.
I thought you guys did your online research beforehand.
Hey, that's our expert over there. Let's go.
We start off with this black gunky stuff, and we end up with clear finished products. The actual distillation starts here, but before we can set it into our equipment, we have to remove the corrosive salts and the solids that can foul our equipment. Uses gravity, and then we also have an electric grid that helps to use the polarity of the water molecules to coalesce them and then drop them out of solution. You can't see it here, but after the oil is heated, it goes into this tower right up there. The tower pulls out different fractions of the crude oil that boil at different boiling point ranges. So we call that fractional distillation.
Whoa, time out, man. I learned about fractions in math class, but what kind of fractions are you talking about here?
The fractions we're talking about here are fractions of the crude oil that comes in. Some of the fractions are gasoline type fuels, some are jet fuel, some are diesel. So here is where we're separating them.
So you mean to tell me that this tower is full of crude oil, that when you heat it up, it's separated into these different components with the lighter stuff on top and the heavier stuff on the bottom, just like the salad dressing in my refrigerator?
Exactly, and that's all determined by what temperature that we choose to operate the tower at.
All right, what's on the bottom and what's on the top? How does it go?
Asphalt's on the bottom, and then going up the tower you have your diesel fuels, your jet fuels, and then in the overhead you've got your naphtha, which is gasoline. So of all the crude oil in the fractional distillation tower, only about 20% of it is gasoline. With some further processing, we can increase that percentage. Those are the liquid hydrocarbons, but there's also some gas phase molecules that come off the tower. Methane, for example, is 1 carbon atom with 4 hydrogens. That molecule goes in the overhead, along with ethane, which has 2 carbons, and propane, which has 3 carbons. Those molecules all have a very low boiling point, so that's why we process them as gases.
Wow, this is some high-tech stuff you got going on here.
Not quite. The basic principles of distillation have been understood by ancient civilizations. It was used to purify water and other complex mixtures.
Which one of these pipes is my gasoline gonna come out of?
Hang on now, it's not quite ready for your car. We still have to do some further processing to purify it. The main impurity in the finished products is sulfur, and for that we need to send it through a hydrotreater to remove that.
Inside, we monitor and control the hydrotreating process. Hydrotreating's function is to purify and upgrade oil. It purifies it by removing impurities like nitrogen and sulfur. And the reason that we want to get the sulfur out is those impurities, if we don't remove them, they go on into the final product, gasoline and diesel. And if you burn them in your car, you're going to have more emissions.
Oh
Oh,
yeah,
goodness.
don't want that.
But there's got to be some chemistry and physics involved.
Yeah, there's a lot of chemistry and physics. It's not an easy process. It's complex. We take hydrogen and mix it with the oil and passes and flows with the oil across a reactor that has catalyst in it. And then we separate the hydrogen and sulfur. The hydrogen's recycled and is part of our efficiency, and the sulfur is further processed and ultimately is a final product that we sell.
So they remove impurities and recycle at the same time? That's pretty cool.
It's more than just chemistry though. There are physics here too. It requires temperature and pressure to make those reactions occur. Yeah, all crude oil has sulfur naturally occurring in it, and it came from the plant and animal life that formed oil in the first place. Yeah, and the amount of sulfur that we remove has actually increased over the last few decades. It's really driven by lowering emissions. So we make what we call ultra-low sulfur diesel and gasoline.
So you're saying what you do at the refinery here makes a difference in what comes out of my tailpipe?
Absolutely. And our mission is to minimize emissions for everyone. So what do you think this is?
Oh, cool. My grandma used to make stuff like this with noodles.
Yeah, this is actually catalyst. And we talked about hydrotreating process. This is what's in the reactor right behind us.
Wait, this is catalyst? So this makes all the chemical reactions happen?
That's exactly right. This initiates and helps promote all the reactions.
So as it turns out, sulfur also happens to be a potentially valuable product that's used in making all kinds of stuff, from fertilizers to other agricultural and manufacturing uses. It's even used to help wash our clothes, preserves our foods, and to make the antibiotics we take. Imagine that, from crude oil. Stick with us, we're about to start cracking molecular hydrocarbon chains. Wait till you see that technology. So far, we've taken our crude oil and cooked it or distilled it into the different hydrocarbon fractions. Essentially, we boiled off the different hydrocarbon chains.
Then we remove the unwanted sulfur by hydrotreating the fuels. Can't have that stuff messing up our engines or the environment.
So far, we've only refined 20% that's in the gasoline boiling range with that distillation process.
So how can we make higher percentages of it from all the different stuff we've already distilled?
See those cracking towers behind you? That's your first clue. Think of those longer, heavier hydrocarbon chains as Legos that can be cracked or broken into different gasoline molecules.
Legos? What are you talking about?
So cracking is always when you take a larger hydrocarbon chain and you break it into smaller pieces, but there's several different ways that you can do that. So there's thermal cracking over in the cokers, and there's hydrocracking in this unit, and there's fluid catalytic cracking in a different unit.
How about thermal cracking? How does that work?
So thermal cracking is when you take a hydrocarbon and you just heat it up. Typical in a unit like a coker, which takes heavy hydrocarbon, it just heats it up, and all these molecules starts breaking up and they flow off as a vapor, and then we capture them. Or you can hydrocrack something like in this unit, which is a reactor, so it's got a catalyst which makes cracking a little bit easier. And this is an extremely high pressure unit, so you put high pressure and you put heat and you add hydrogen, and on this catalyst you actually have to cool the reactors down because you generate heat when you crack them. The other way is we have a unit that has a fluid catalyst, so it's a catalyst that spins in a circle, so we use steam and other hydrocarbons to keep it moving in a circle.
What are catalysts?
So catalysts are materials that help either speed up a reaction or make a reaction more selective or change the conditions that a reaction will occur under, so different pressures or temperatures. So catalysts can contain specific metals like platinum.
Platinum? I better keep my eyes open then.
So one of the things that makes cracking so important here is that we take a heavy hydrocarbon that wouldn't be useful in your car or on the roads, and we crack it into gasoline and diesel and other products that are much more valuable.
Kind of makes you wonder, can it take smaller hydrocarbon chains and enlarge them to make gasoline?
Well, we talked about cracking and splitting apart molecules. Let's talk about putting molecules back together. One of our units is called the polygasoline unit. And what it does is take small molecules and combine them together to make gasoline. And here's the process. We take light hydrocarbons that are like propane, that we call propylene, and we bring them together across a reactor and through a reactor, and we recombine them together. And that makes polygasoline. Other people can use propylene, and you can make not gasoline, but plastic.
Oh yeah, you never know when you're gonna need some plastic.
What's the role of physics in all this?
Yeah, the physics in polygasoline is temperature and pressure again. It takes 450 degrees to recombine those propylene molecules, and it takes several hundred pounds of pressure. And another way we rearrange molecules is by reforming and reshaping the molecule. And what that does is increase octane on gasoline. That's upgrading.
That took some serious technology. But I think you guys missed something kind of important. See all that steam over there? That's your first clue. The second is the name of our show, Into the Outdoors. Because we're environmental scientists, we need to know their impact on the water resources there. Looks like they use a lot. Now go get them.
We see that you use all kinds of technology to turn crude oil into transportation fuels. Now we also need to know if you use similar technologies on stuff that you can't sell to gas stations.
Yes, so we also use water in the refinery. So water is cooled and used to cool the process. We also boil it and turn it into steam, and then it's used as a heating medium. And most of the water in the refinery, either it disappears in the clouds that you see, or it gets discharged to the Mississippi River.
Discharged in the Mississippi?
So before the water goes to the Mississippi, we treat it in our wastewater treatment plant. We separate oil out of it in gravity separators, and we also chemically remove oil. And then the coolest part is that the water goes through what we like to call biobasins. They're actually called activated sludge basins, where bacteria digest all the material in the water.
Yeah, but do you test that water before it goes back into the river?
Absolutely. We test for several different parameters. Among them are oil and total suspended solids and different metals. There's also something called a whole effluent toxicity test, where small water fleas and other aquatic species are put in the water, and then they have to survive for a specified amount of time.
Now that we've refined all this gasoline, it doesn't do you any good if you can't put it in your tank, and you sure can't fill up here. Coming up next, we're going to unravel the transportation trail of getting this stuff into gas stations across the country.
Find out how industries use technology to protect the environment at intotheoutdoors.org. Think about it. All those thousands of gallons of gasoline that we refined earlier won't help your car get down the highway if it's in some tank back at the refinery, right? That's where the pipeline connection comes into play. Even though we can't see the hundreds of miles of underground pipelines, they're like arteries in our body, pumping fluid to vital systems. Here's the deal. Once it's refined into different fuels, other pipelines pump the various fuels to separate storage tanks. Then, other pipelines pump the fuels to distribution terminals and key airports. Then, tanker trucks or smaller pipelines supply gas stations and industry with the fuels they need to serve their communities. And look, that's you and your family gassing up at the pump. Ta-da! Where you been? This pipeline thing is huge. I could use a little help.
I've got it covered. Take 5 while I try to unravel how this pipeline functions.
So the oil fields where we get most of our product is North Dakota and Canada.
So it starts its life up there, hundreds of miles away from this facility where we're currently standing and where our refineries are located. So we have to get the oil from there to here. Since it's a viscous substance, we can't just rely on gravity to flow all the way to the refinery. So we have pump stations at set intervals up and down our line that add pressure so we can push the product through those lines and deliver it ultimately to this facility.
Instead of having a lot of different pumps, why don't you have just one really good one? I feel like it would save you a lot of money.
Well, we have to take in consideration the hydraulic gradient of the line. As the crude oil flows through the line, it has the resistance to flow. So we have to overcome that resistance. We need the pumps separated out so we can evenly push that product through the pipeline.
I remember one time I actually paid attention in physics class, and someone said something about fluids and viscosity. Do you have to deal with that?
Yeah, absolutely. Fluids and viscosity, that plays an important role in this type of industry. So we have to make sure that we keep our fluids moving at a constant speed, a constant rate.
Somehow you got to keep it warm.
That's how you keep it warm. You keep it in motion, keep it moving in a certain direction, then you keep those molecules moving together, bouncing together.
So it flows better.
Flows better. Increase the heat, increase the flow.
Okay. I think I could get a job here.
Hey, we're hiring.
Really?
So some of the challenges that we're facing today is being able to keep up with the demand signal. Being able to transport fuel via piping system is about 71% of the market. Ships to be able to transport via water, that's only about 22%. You see those big trucks on the highway, they're only transporting about 4%, and then you have railways that only transporting 3% of refined products throughout the United States.
I don't know that it's such a good idea to have these big trucks filled with petroleum fuels, especially if I'm driving on the road.
I fully concur exactly what you're saying. That's why it's so important for people to understand that crude oil and refined products is transferred mostly by pipelines. And that's the safest way for us to actually transport those fuels.
Recently on the news, I just heard that an oil company had an oil spill when a pipe leak.
Since 2001, the number of pipeline catastrophic failures has been down by more than 60%. However, in order to be very proactive and making sure that that doesn't happen again, that's why it's so important that you have a very active integrity management program. That's what we call it in this industry. Integrity management requires us to have those different types of smart tool technologies to run through the pipeline and continue to assess the pipe, especially when the pipe is running underground and we are not able to see what's actually down there.
We also call them smart pigs, and we also use the terminology inline inspection tools. They're devices that we insert into the pipeline. They move through the line just under normal flow conditions. There's a whole bank of sensors all the way around the tool that measure different properties of the pipe. We can measure things like the wall thickness, deformations, so like dents. We also collect data along the pipeline, so we have GPS coordinates, almost like a map of our pipelines when we run these tools. So they find any potential issues before they become a leak. So we're proactively going out and looking at our pipelines before we have any of these issues and making repairs to the line.
Our integrity engineer, he delivers what we need to go dig. We use the GPS coordinates, and then they dig with an excavator down to the pipeline. They remove the top coating, and then they assess it. They do a non-destructive evaluation test.
And if it turns out that the pipeline needs repair, they either weld a steel sleeve over the section or complete another kind of integrity repair. And that's how pipelines work. Back to you guys.
Yep, I'll admit, the gas in our tank will never look the same again. See you next time on Into the Outdoors.
The following organizations have provided funding for this Into the Outdoors television series.